All right, everybody, welcome back after our small intermission. All right, so we finished off talking about the replication. Um, yeah, I guess before we kind of go forward, do we have any questions so far? If not, that we can proceed with outlining exactly how the database would look like. So what we'll do is that we'll have I guess at this point we can kind of walk backwards towards our design. Um, I don't actually think it's gonna be enough space. Let me make a little bit more space for me here. I'm gonna take all the requirements here. I'm gonna make them a little bigger, more readable, and I'm going to increase this stand a little bit more so we can fit our databases in here. I'm gonna expand this, make it bigger and nice, and we're going to talk about databases. So first what we'll do is that we'll have um, a cluster of the SQL databases. So what we'll do here, we will have a primary. This is going to be a primary, and we're going to have many secondary databases. Now that we just had a refresher on this, this is going to be easier to follow. Now this is going to be many secondaries. Now what we'll do is there's going to be some APIs that will be writing to primary. So this is going to be our write flow that is going to be accepted through the primary database. And what will happen here is that we're going to have the async replication along many secondary nodes, and then we'll have the read flow. The read flow is going to go exactly to the video API, and there's going to be another API that will do for the upload. So before we dive into very complicated API that is the video feed API, we'll talk about actually we also have the NoSQL database part, which is going to be right here. And here what we'll do is that we'll do NoSQL. So this is going to be for the telemetry.
Matt,
Mm-hmm.
can you speak a little bit more? Why do you choose a string replication instead of strict consistency for this one?
Yeah. The reason why we decided to choose eventual consistency is because we're focusing on latency and availability, and we're not so much worried if the video is going to be uploaded. We're not necessarily interested in being able to see this video right away for everybody, but instead we'll prioritize availability. So for example, if we have a strict consistency and one of the node dies, what we'll do is that we would need to make sure that the node is removed from the cluster and everything is up to date before we can serve the read flow again. And in this case, if the node dies, nobody really cares. We will continue updating asynchronously the nodes we have, and then we'll use the auto-scaling groups to just boot up a new node as we need. So since the requirement of the problem does not, there's not really requirement for the problem to have some very strict availability or the video be available immediately, we pretty much can ignore half of the nodes and strict replication. But it's a great question. I hope I answered it.
Yeah, you did.
Yeah. So, and for the replication, again, why we chose primary to secondary is because our application is a very read heavy, and we have a eventual consistency. So that is something that is very good for the read heavy flows, is that we have a separate cluster that serves all the read traffic. All right, I hope that makes sense. And also for um, NoSQL databases, what we will have is what we'll do, we'll have a MongoDB tables, and instead of for us, what's really great about MongoDB and NoSQL database is we have easy scaling. We don't have to worry about partitioning or sharding. And for SQL database, we'll talk more about how we're going to shard exactly the database for easier reads and writes. So MongoDB will take care of this, and again, MongoDB will store document like storage for logs and business analytics. All right, now we have the databases we have. Now it's a very good time to talk about cache. So why cache is important is because when we're working with a low latency application, we need to be able to feed the videos very quickly. So now we're going to talk about the machine learning service. This is going to be a service that's going to supply user feed generation machine learning service. So what the service does, it basically takes let's remove the server for now. So this service is going to be called from the video feed API, because we just supply the user ID and we want to get the videos for the user. So what we'll do is that we'll make a request. It's going to be gRPC. This is going to be very fast request. It's going to be gRPC. Since we're inside one virtual private cloud, between two backend services, we can use gRPC instead of REST to achieve low latency calls. And this, what we'll do with this gRPC call is that we're gonna ask the machine learning service to give us videos for the user. But instead of talking to the service directly, we'll introduce something called pre-cache. Something that pre-cache can do for us. Pre-cache can store very simple thing. It can store, we can use Redis for this since it's going to be key value paired. It's going to have user ID, and it's going to have 10 links to the signed AWS S3 Amazon. The link looks like Amazon.com video blah blah blah, some video ID. So we will have 10 of those links in this cache, and this cache is going to have I'm running out of space again, but I do want to be very specific on what exactly is going to be stored in this cache. So this is going to be 10 videos of what the user, what we would need to return. And this is going to be our Redis cache. Okay, and what this machine learning service will do is that every single time this is going to be every single time how this works. So we'll call the machine learning service to get the videos for given a gRPC low latency call. Here it's supposed to be here, and we're given user ID. So now the exact flow is going to be to see if we have anything available in our pre-cache. So step two. Step 2, check our pre-cache storage. Now, if we have something available in pre-cache storage, we'll return it. Otherwise, what we'll do, we'll create one video and return it right away. So the response from this service is going to be just the user ID, some numbers, and the video link. And can you guys tell me why we're just returning one link here? Chat? Why only one link? Edmund?
I don't want to answer. I want someone else to answer.
Okay, yeah, that's fair. Chat? Keep? Why only one link?
Messes are totally fine, even if they're wrong.
Yeah, that's totally fine.
My guess is to minimize the request size, right? Because one link means just a piece of smaller data size.
Absolutely. The whole goal is to minimize latency, because we want the service to be as soon as possible. So, for example, you scroll in TikTok and you want to make sure that you get your video as fast as possible. So you would want to just have one link. But then the most interesting part of the service idea here is that what we'll do, let's do it like this. Now, once we found out that this user is actively watching videos, we can now proactively, this is the key portion, proactively start populating cache. So now what will happen is that once we know that this user is engaged in the platform, we can actually make our cache just a little bit smaller, so it's a little bit more compact. It's our Redis cache. Now we know that this user is actively watching, so we proactively prepare more stuff for the users to watch. This way we can pre-compute with the machine learning algorithms all the links that we want to see ahead. So let's write down all the benefits of this approach. First of all, we want to pre-compute all the videos the user will see in the feed. And secondly, if all users make a request at the same time, we have enough time to schedule and pre-compute. Because what happens here is that if the service is under high load, we don't have to schedule the pre-cache process all the time. Instead, we actually have plenty of time before we need to supply more links. It can be as long as 10 minutes per user to actually make another request, because pre-cache will supply 10 videos at a time, and then it will only then ask for more. And so what happens at the end is that we'll return from the machine learning service back to the video API. So now we have the return flow that will return the links, either a link or 10 links, and then we will, from the video API, we're going to write back to the user. And what's going to happen here is that the iOS application will start UDP download of the video on the S3 bucket. We can talk a little bit more in depth why UDP or what is the other TCP, and the reason why favoring to use UDP is because since the requirement was to have under 100 millisecond of latency, we can actually talk about how long it's going to take. So assuming that average user will have about 30 megabits per second internet speed, maybe they're on like a hotspot or mobile device, and the video takes about 3 megabytes, maybe 3 to 6 megabytes to down size, we can actually calculate 3 divided by 30. That's actually, yeah, that's actually comes out to be 100 milliseconds to download the video. But the problem with this is that this is very tricky, because then we also need to make sure that the server that's going to be the CDN that's going to be providing the links is going to be very close. So we need to partition and deploy S3 buckets all over the world. So what I will do here is to give myself a little bit of a buffer, is that I will use less of the speed, because once I can make a little bit of sacrifices in the video quality, since the primary goal here is to, it's okay if like one frame of the video is completely black or corrupted, as long as the video is delivered very quickly to keep the user engaged. So this is why the reason for me to use the UDP over TCP on the mobile app. So I know I've talked a lot, and now I'm expecting a ton of questions from chat. So questions about cache and pre-cache, how that works, question about UDP TCP and the entire flow of the machine learning service, anything really from what we've said, or any comments really.
I have two questions.
Yeah.
The first one is for the machine learning service. You said you create a one video. What do you mean by create a one video? Do you mean like go to the database and get
Yes, sorry,
a video?
that's an extremely great question. Absolutely, and this is something that we will absolutely happy to discuss more. What we'll do is that we have this MongoDB table, and there is going to be some black box communication between MongoDB table and the machine learning algorithm, and then it's going to do some black box magic to do ML AI recommendation system. So that is not something I'm expert enough to cover at all. So we'll definitely just use some actual machine learning to determine, based on some telemetry in the users, how exactly this video will be determined and given back to the user. But that's an amazing question.
My second question would be, what happened if your machine learning service like fail? Like how your system handle the situation?
Oh wow, that's a really good question.
Yeah, define fail though. Are we talking like the service is not up, or are we talking about like the actual algorithm that we constructed? Like, because like,
the
failures in machine learning.
Yeah.
The first one, so the service is not up, right?
Yes. So
okay,
when you
so usually you're gonna want to have a check. It's essentially you're gonna want. So remember how were you guys asked about telemetry previously?
Mm-hmm.
So you're gonna want a telemetry not only for the product that you're servicing to the user, but you want telemetry of your internal systems, right?
Yes.
So this is where essentially debugging and logging comes in. So you're gonna want for all of these processes, and it's not covered now because it's usually kind of inferred. You're gonna want logs of everything. So not only what you're sending, right, but you're gonna have to also have conditions of how is your machine learning gonna respond to a failure, right? And how are we gonna detect failures, right? Like, are we talking like?
Yeah, I think the question is like call to UFGMLS. That stands for User Feed Generation Machine Learning Service. Response with 500s. I think that's that's the question is, right. So basically, we're making the gRPC call and we get a 500. That's a really good question. And now let's think about it. So now let's kind of take a snapshot of this.
Wait. Before before delving into that, like unless that we're designing also like the machine learning like system too, um, I don't know how much of a concern it would be. Like if they're doing a product building.
No, I
I mean
think
that's what I'm
the
thinking.
question is still valid because it doesn't have to be a machine learning service, right? It can be just you have a very important API that does all the work, and what happens if this API
Okay,
rejects
okay,
our
and if you're
content?
just trying, okay, okay, I see how you're framing it. Okay, yeah,
Yeah.
yeah. See.
So yeah, I think it's a really good question, and I think that I have a quite a bit of a answer here, and that's exactly a really good part to be focusing on. So I'm gonna form my answer in two things. So first, we're gonna talk a little bit more about developer tools. So we're gonna have at our company, we're going to. So let's talk about the reasons, right? Let's talk about what are the reasons why 500s can happen. What basically actually will define fail, right? Let me go back to the pencil. So let's define failed. So what can happen? A, server service is down because of the node issue. We heap ran out of heap memory. CPU utilization or is like 85%. Right, the server will start failing at this high of a CPU utilization. Let's say we can also have node can node stop responding to heartbeats, right? So this is one reason the service can become down. Or the second problem is there is a software error. There is a software error. New deployment caused bad code to be deployed, and we have a faulty service. And there can be a dependency issue. Cache is down. Database is down. Other dependency is down. So now I'm going to answer your question based on these 3 points. So what happens if the service is down? So let's kind of take a snapshot on what happens when we call something over the gRPC. So we're gonna have, let's kind of pretend this is the call again. This is the call with the gRPC call with user gRPC call with a user ID. So what happens is that we're gonna have a load balancer, internal load balancer that will maintain something that something that is called an auto scaling group. And let's dive deep into exactly how it works. So let's go here. And this is actually not unique to the machine learning service. Every single microservice at our company will be deployed and maintained in this exact fashion. So how does auto scaling group works? So we have division. We will have zone US East. We have zone like US East is going to be probably like Virginia. We have US West. Usually it's Oregon. We have EU West. It's probably London or Belgium. Then we have EU East. It's going to be like Germany or something like that. So this is going to be the regions in our auto scaling group, since we're deploying worldwide. And now inside of every single auto scaling group, we're going to have nodes in it. So usually what they call is A1A1, 1A2, 1A3, all the way to the nodes. And every single auto scaling group actually contains more and more servers. So this one, for example, can be 2 out of 4, this can be 4 out of 5, and this can be, let's say, 22 out of 10. And this is going to be, and now you can ask me, well, actually can be between 2 out of 10. 2 out of 10, right? And now you're asking me, why do we have 2 out of 4 service, 4 out of 5, and 2 out of 10? Well, that's because the auto scaling group, how it exactly works, it scales and descales based on the time of the day and the traffic in this region. So, for example, there is no point to hold all the service in US East when there is night and there is not a lot of traffic there. And there is basically no need for this. And they will descale and scale up automatically as required. So now, what is a very important distinction, I was going to answer the second portion of my question, is this is a production. So this is auto-scaling group is a production. But what I will do here is that I will repeat this thing in QA. And this is going to help me answer the second portion of this question. So this block right here represents that we're going to be deploying auto-scaling groups in multiple sections of our network. So we have a VPC, we have a prod VPC, and we have a QA VPC. And this will allow us to do the same thing, to do how we're going to deal with the software errors. So we're going to have a tool in our company that is going to do deployments, and how deployments will be done. Every single deployment is going to go through these following stages. So the first deployment is going to be deployed at a local dev instance. So every single developer at our company will push their code to a local node in AWS QA, but it's going to be personal EC2. And for example, in my case, it was something like EC2 and then some ID prefixed but with my last name. So this is the first point of note. Once this deployment is completed, we will run the test cases on a Docker container that will take this code and run all the tests independently. Once all these tests pass, this tool will notify the code our code hosting platform, GitLab, GitHub, etc. After this flow is completed, we'll enter in our pipelines. So after this is done, we're going to enter our pipeline. So the first stage is going to be staging. Stage 1, staging. So depending on the requirements of the service, we will have multiple commits staging here. So you can pretty much imagine like this is going to be the further error, and you can see the danger zone starts kind of here. So here we're going to wait for commits to be ready to be deployed. And I want you to notice that this is not going to be a CI/CD pipeline for our service that is called, what is it again? UFGMLS, no CI/CD. And the reason why we're not going to have a CI/CD is because of a very sensitive service. It can bring the entire system down. So our architecture for deploying this service is not going to be a CI/CD. We're going to have a mechanism that will wait for commits to be accumulated, and we're going to be deploying this thing once something called an MCM, or we're going to call it, not to call it the same thing, we're going to call it approval letter format. So we're going to have an ALF. Once the ALF is approved, ALF approval needed to go forward. So this is something that every single commit has to be staged. And here, oh wait, where is it? So this thing will point to commit hash of the commit to be deployed. For example, it can be like something like this, and we'll reference the every single pipeline. So for example, if the UFGMLS is created, contained within multiple multiple repositories, this thing will be per repository. This is going to be per microservice repository. Okay. So what will happen next is that before we actually move to QA in production, we'll run tests. So that's going to be another step. So just to clarify, this thing needs approval. So this is like a button here. I'm kind of drawing the actual UI of the tool. Need approval to proceed. So we need approval to proceed to this stage. And then what happens here is this going to be our test suite. This is going to be our test suite. And now you can, this is what I'm going to add in our test suite. I'm going to add integration tests. We're going to have an endpoint that's going to basically run, dry run. We're going to have like some random user IDs, and we're going to run integration testing against it. And we're going to make sure that nothing breaks. We're going to have chaos tests. We're going, what chaos test means is we're going to inject failures and see how it runs. And see, here's and see. Now we're going to have stress test. What stress test does, it tests the service under immense high load. Now we're gonna have a smoke test. What a smoke test does, it deploys to one instance. And then all this test suite will do for every single repository, and we will see the result here. And here also would need approval if not passed. So there is some cases that we'll need to consider is that we're doing an emergency rollback deployment. The tests will sometimes fail because the tests themselves are not good enough, or sometimes they're just faulty. So sometimes in a case of emergency, we would need to have this thing bypassed, and for this we would need an L6 SDM approval. So we would not be able to just would not be just like anybody. Not everybody can override the test suite and just deploy it. Okay. Before I ask any more questions, I'm gonna go just a little bit more in depth into the architecture here. So now we're going to have the QA deployment. So this is going to be our QA. Here we're going to take the auto scaling group, and we're going to deploy YOLO style. And before you guys comment, this is an actual terminology. I did not make this up. What this will do, the YOLO style terminology, it takes all hosts in one auto scaling group. For example, 1A1, and kills them all, boots up the new nodes with the new code version. All right. Honestly, I'm not sure if we're gonna be done in 3 hours, so buckle up. I have a lot more to say. Okay, so guess what happens again after this? We need another test suite that's gonna be right on QA, because we made some changes to the machine, so we're gonna run all the test suite again on QA. Now after this is approval, this is also needs approval. Now we're gonna deploy to one AZ. We're gonna deploy to one Pro AZ. We're always going to deploy to the least business important production AZ possible. So we're gonna do small deployment. Somebody really dropped after you said 3 hours is not good enough. Okay. Okay, that's funny.
I mean, it's a Friday. Scary.
It's a
It's
Friday,
scared the
yeah. It's a
hose.
Friday means I can stay up longer tonight and lead code in the morning tomorrow. That's what Friday means to me.
Uh,
Okay, so small deployment to least important business region. So we will have metrics to adjust the pipelines as needed, but we're gonna deploy to about 10% of hosts in this region. This is already production, so I want you guys to be very careful. This is already production. So production starts here. This is already production. This is prod, guys, and this is usually it's always CN. Usually it's always CN. Not gonna say, but this is prod CN. Very special. We're gonna deploy there always first. Then what's gonna happen is that we're gonna be this is gonna be prod CN partial. And now what we're gonna do, we're gonna repeat this. We're gonna repeat the production deployment. And now let's do it for full CN. Now it's gonna be prod CN all. And this will repeat. And now for, I'm just gonna write in the text, it's gonna be EU partial, then it's gonna be EU, then it's gonna be SA partial, then it's gonna be SA, then it's gonna be NA partial, and then it's gonna be NA. This is the business region strength and importance of business in terms of how much revenue they would bring to us, and we'll always change it if our business analytics teams find something wrong with this. So we talked about auto scaling groups. If any hosts die, they can always be restored. We have managing for here. And yeah, so this covers the second point. New deployment caused bad code to be deployed. We have a faulty service. And if there's a dependency issue, let's say MongoDB, AWS is down, we will reroute traffic. If they're down only in one region, we're gonna rebalance them in our load balancer to another service, and we'll try to serve traffic from another region if we can. But if dependency is down, AWS is down worldwide, there's nothing we can really do. Everything is gonna be down anyway. So this is kind of the most we can really the most we can really protect ourselves. So we have a really good test suite. We have a lot of protection from the code errors. We even sacrificed the time it takes to deliver code to the production by using ALF, approval letter format, which is I just made up as well, a custom process that requires multiple approval steps before I move to the next step. And there's also a very important thing to talk about is also our canary. So let's kind of start a new suite right here, and we're going to talk about canary and how exactly that's going to work in details. How the canary system would work is that we will feed where is our MongoDB telemetry. So this MongoDB telemetry will once we're going to be writing all the logs, we're going to be feeding these logs to canary. And what it will do is it will parse the logs into like a monitor. I'm gonna try and like draw it out. So the monitor will be basically connecting the dots of how many errors would happen per 100. So for example, like this, what this would mean is this is issue. This is going to be like this is going to be, for example, user video not shown CN error per 100. This is, for example, the title of this graph, and we're gonna have the errors on here, and we're gonna have some time here. So we're gonna be able to live kind of see the telemetry, like the errors like this. So it's gonna be our canary system. So that kind of covers your. I hope this answers your question, Heap. What will happen in case the GMLS is down? So yeah. Any questions about now? I guess this portion of design.
Yeah, thank you, Matt.
Is this good answer to the question?
Oh yeah, yeah.
Okay. All right.
Um, sorry, I just want to follow up one last time.
Yeah, absolutely.
I might interpret this wrong, but is there any every request to the machine learning service is that synchronized or asynchronized? Is that when you make a request of it, right? Do you wait until the request complete to go to the next one? Uh,
We'll I mean, what do you mean wait and wait until what exactly happens? Sorry, just.
yeah.
Mhm.
So like, for example, right, there are like 50 users send a gRPC request to the machine learning service, and none of them have any cache. So they're gonna go to the database, they're gonna pull out the level one video and send back, right? And a response.
Mhm.
So the whole process is that synchronized or it's a synchronized process,
Oh,
right?
that's an amazing question. So that's exactly what's going to happen in this case. So we have the gRPC call with user ID, and the load balancer will do round robin partition to put them based on their region into the and the node from the auto scaling group will answer the request. I think that max cons, so maximum concurrent connections, for M4 X5 large, which is the choice of the node in the auto scaling group, I think it's about 200. So we can have about 200 threads running per node in the auto scaling group. So every single node would be able to serve 200 requests per this. But if none of them, yeah, if none of them will have the answer in pre-cache, they will actively compute the answer and wait. I guess they will wait for the answer from getting at least one link. So we'll be able to use some levers to adjust down the maximum concurrent connections. So that's something that is also like a very good understanding here is that, for example, if we can see that the requests are timing out, and there's going to be like I think like a 3-second timeout. That's I think very important to mention here as well. There is a 3-second timeout here. The 3-second timeout before we fail the request and the user has to reload the video. Very important that it's not like very long because we don't want to have any bad traffic. And by the way, we are targeting 100 milliseconds. I guess I should have mentioned this earlier, but 100 millisecond is a P50 metric. So median of all video uploads has to be under 100. So it's acceptable for P9999 to be a 3-second timeout in case something does go wrong, which is a very important detail I should have clarified as well. But what we will do here is that what's also going to happen if there is a lot of requests that are timing out to UFGMLS, we will have the maximum connection lever. So we'll also have a lever suite. Let me touch the lever suite. So lever suite. So what this will do is that this is something we can adjust in runtime. That will let me make it just a little bit smaller. This is some things we can adjust in runtime to have a control over of our service. So we'll reduce one of the things I would want to have is reduce max cons on node. So something we can see is that as you mentioned, right, we don't have we have a lot of new users coming in. None of them get a cache hit. What we have to do is we have to wait. We have to do a lot of computation to go to the and to the black box system with ML and wait for the response. And the same architecture would apply to the service as well. So if the service has to do now a lot of work and a lot of things needs to be done at the same time, we usually would serve 200 maximum concurrent connections. Basically means we have 200 threads running on a server. And what this can result is that all these connections are very busy and they are all very computationally intense. The CPU utilization can start running out, going way too hot. The temperature can get way too hot. And what we can do in a tier 1 emergency response situation, because it does a little bit, it takes about like 5 to 10 minutes to scale up. What we would want to do is that the on-call engineer would want to reduce maximum concurrent connections. What will happen is something called a VIP spillover in case this happens. So the spillover basically happens when we don't have enough capacity, and on the load balancer will start rejecting traffic. and not processing those. But reducing maximum concurrent connections is a good thing because we can save overheating CPU. We can save an overheating CPU from getting way too hot and processing way too many things. But we will start seeing a VIP spillover. Basically, all the requests to UF, what is it again? UF GMLS will start failing, but all the requests we're able to get through. If in case we're underscaled for like a high traffic event, we will be able to save at least by not like killing our hosts. And at this time, the on-call engineer will start conducting a high emergency, very quick response to scale up our service. So that's something that we can do. Another thing we can add to our lever suite is that we can add AB protection. So AB protection basically means we will deploy some portions of our application behind an AB flag, and that can be toggled and deployed in seconds. So how that exactly works is that instead of us having to deploy and go through LFP approval letter format to do a full suite deployment of the entire application, the AB protection will allow us to toggle the flag in a desired region in seconds, and that will basically, let's say we just deployed a new portion of UF GMLS that now takes more parameters to our system and it's much more computationally intensive, and we're spilling out. We can roll back to the more sophisticated version of UF GMLS and take maybe like less fancy approach that would be a little bit easier. I know it would work for this type of traffic, so we can roll back to this to this protection. So that's something that we will do. Does this kind of answer your question? How we'll prepare for this?
Yeah. So I heard you mention about the level suit with and then VIP spillover. Is that's one of the rate limit mechanism, right? Like you don't want to like the user send too many requests.
Yeah, well, of course, we can actually expand the test suite. As we mentioned, we can add throttling. We will absolutely need to throttle requests. What we'll do is that we can, when we're running a test suite here, when we're running the stress test, we'll know we'll know that for every single node, for example, for M4 X5 large, we'll know the certain TPS it can handle before dying, and we'll start throttling. We'll definitely add some throttlers that will start killing the request on the node level. So just to be very clear, so max cons is going to be on the VIP level or load balancer level, and throttling is going to be on the node level, basically just rejecting all the incoming traffic once we're reaching the TPS that is way too much. Once we're processing way too many requests, we'll start throttling them. I can actually move throttling to load balancer as well. That's totally fine. There's not much difference here, as long as we throttle the incoming traffic and reject the responses, which is a very bad case scenario, but it's better than our nodes just dying. And again, we'll have absolutely on-call engaged at the point that throttling will start working. So that's that's something that is very important, that we do throttle the request as well if we see that the system is dying.
Gotcha. Do you have any retry mechanic? Like say for request app, like you have a timeout limit, right? After the request is timeout. Do your system support any retry mechanism in this case?
No, and the reason is that we want it's too slow. We're targeting availability of 99.99, and we're targeting P50 to be at 100 milliseconds. So if we consider a very interesting mechanism of exponential backoffice, like we make a request and then if 3 seconds goes by, it doesn't come back, we need to make one in 9 seconds and then 81 seconds. So that is actually way too slow for this application. So what will happen is that the user will just see a black screen, and if they attempt to swipe up again in the app, we'll retry again the full request, and we'll retry again. That can actually cause the throttlers to begin active, and that's why a very important thing why we need throttlers in the first case is because when something fails, usually when something fails, the load goes up because users will retry themselves, and and in this catastrophic situation, we will need to engage throttlers and scale up insanely fast. But something a recommendation I can give, running CPU utilization, we can leave our machines running at CPU utilization of 50%. Since we have really good and predictive traffic, we pretty much would know when we're gonna run the app that this traffic would be able to be at like 22, 23 TPS. We can run the stress test. We can figure out maybe our server can run 50% CPU utilization, 60 Celsius hot at 150 TPS. We can leave that at that. We can honestly sacrifice a little bit of capital into overscaling a little bit just to make sure we're right. But I don't gonna have to go super crazy. I'm still expecting the CPU utilization to be constantly in double digits. I'm not gonna recommend to leave the service to be running overnight at full scale. We can totally descale at night. Something we do have to be careful is that, from my experience, when you have an auto scaling room, sometimes there is an issue where it wouldn't scale back up. So I wouldn't go too crazy, going scaling down as well. So if my night traffic maybe has like a few hours of night when the CPU utilization of the fleet is about like 5-10%, that's fine. I want the daily traffic to be able to be handled, even if in a case of emergency we're not gonna be able to scale back up if like the provisioning service is down. We're not going to be able to scale back up, so that's going to be an issue here. So I don't want to go crazy on this scaling either, but throttling, very important. We definitely, once we have a situation where we have a lot of retries, I definitely do not want the users to completely kill the rest of the machines. I will throttle their requests and redirect them to a shop or another page instead of retrying. Yeah, if that answers your question.
Gotcha. Yep, that answered perfectly. Thanks, man.
Yeah. So the lever suite can definitely be expanded further. Um, this is kind of like the three key ones I can think of: the max tone, the AB protection, and throttling. And usually, if you want to make custom levers that are not on the, um, you would basically kind of expand point two. Instead of just having like an AB protection like overall lever, what you would do is instead you will have a lever that is more specific to uh, to the feature. So for example, you could have a dog video prioritization lever. So instead of let's say your system now expanded to a new feature that is serving dog videos much more often, and it has a proprietary algorithm that serves dog videos much more often. You could have a custom lever for that feature to turn it on and off, and that will be considered its own lever, and we can turn it on and off again if we know that this lever does affect the system performance or availability in any way. But speaking back to the 5 nines, the requirement to be reliable, absolutely, throttling is the key portion to keep availability high. I've seen systems do 5 nines over very high traffic when we have throttling, and we have very good understanding over maximum concurrent connections, and being able to reduce them at once, and we have really good understanding on how hot we can run with the CPUs for every node. So that's kind of it. So with that in mind, any more questions on high traffic, how the high traffic works? That's kind of my uh, really good area that I'm very much have a lot of experience. I've scaled some services. I was I scaled Amazon.com orders to high scale traffic during Black Friday. I had to do system design, scaling, and all the mathematics and present it to a big committee. And yeah, that was kind of the biggest project I've done. So I have a lot of expertise talking about levers, scaling, our scaling groups. So I'm happy to dive as deep as you guys like me to. I can dive much more in depth and talk about it if you guys are interested. Chat, am I alone here?
No, no, speaking. No, I think honestly this is good for now. At staying at this level of depth. But I do want to. I'll talk to you later about the resource that you use um for getting to like a more like nuanced perspective of like the metric behind scaling systems such as this.
Yeah, absolutely. I mean, I'm definitely open to feedback. I'm not speaking the truth. This is just what I did before, and this is what I know. But
Yeah.
I'm happy to address any gaps in the knowledge. I'm pretty sure I have a ton. Uh, Kind of worried about my interview for system design. I don't know if this is good enough for a senior.
I think this is pretty good for junior.
Mm, I don't know, man. I feel like I still have ton of depths, ton of misses here. So I
And
would
databases?
databases and consistency application. If I get like an easy problem that focuses on scale, I can probably answer it on a good level. But yeah, I have to do a lot more deep diving here. So, any questions?
Just my 2 cents.
Mm-hmm.
Yes, I think the system will benefit. If availability is the main focus, right? I think your system could be benefit from message queue. It's especially the part where it goes from the service to the database. Remember you said like if the hardware issue when database is down and other patch is down, stuff like that, and the whole
Mm.
basically the whole system goes down. If you have a sort of like a decoupling method, like having a message queue in the middle, you will be able to avoid that situation. Basically, message queue will not reply if the database is down,
Mm-hmm.
but your user will not be having like a total like the system doesn't total crash stuff like that.
Uh-huh. And is the message queue usually in memory, or is it like persistent?
Um, it, it could be persistent. I haven't seen message queue that in memory for a while, but usually it's the independent service.
Mm-hmm.
Set in the middle, yeah. And the whole point of it is to decoupling. Like if one part of it's fail, the other part is still be able to sort of function normally.
Is this
Um,
for the reads or for the writes though? Because
um,
I'm not sure if there's one for the reads.
is I think it's for the read, right? We're talking about user sending requests to get the user feed, I assume, right?
Yeah, user send a request to see a video. So I was thinking message queue is gonna be good, like if you can't upload a video right now, but you still have it in a message queue.
Mm-hmm.
But for the reads, I was thinking like you straight up hit up the database and see if it's there.
Yeah, I mean that's true. That's totally correct. The ride would benefit a lot too on the message queue.
Mm-hmm.
Um,
Yeah, but I can totally see if we're writing something to the database from GMLS, it's totally good for for making sure we don't actually miss any data and we keep it in case the MongoDB is down. We can keep it in the queue.
mhm.
All right. Um, how are you guys feeling? Are you guys still okay? Tired? It's been almost 3 hours, 2 hours and 50 minutes. Um, you guys still listening? Are you guys still enjoying, or is it already like too much?
No, no. I mean, well, okay. I don't want to speak for everyone, so I'll go first.
No, this is good. This is probably a little bit too in depth for like regular 45-minute interview for system design, but I think
Oh, bro, this. Oh my God.
Yeah, yeah. This is not for an interview. This is to just like design a system as better as you can.
No, at this point, the interview would be slitting the wrist or jumping off the window. Um, no, this is good. This is really, really good. I haven't really thought in depth of systems. I mean, to be honest, I can't think of any resource online off the top of my head that's not like at least product specific that goes this in depth for system design. Um, which is really good. I think maybe give it one more hour till like 10. After that, I think it'd be good to cut it off. I don't think anyone else is gonna have bandwidth after that.
Yeah, we still have the upload thing,
Yeah, we have the upload and we also have the
like, follow, sign up, and then
login. Login sign in
notifications.
is gonna be
Yeah.
fairly straightforward. I'm not too worried about that.
Okay. You guys want to do another break? I'm kind of tired, but I don't mind keep going. I just need like 5 minutes.
I think I'm gonna pass out now because I'm Eastern time.
Okay.
But
Oh,
is there a
bro,
way
go to
like
sleep.
could you like share the Excalibur by any chance?
Yeah. I said I'll definitely share it.